Good evening, everyone, or good afternoon, or good morning, depending on which part of the country or the world you're joining us from. My name is Sam Nasser, and this is the Cleveland C# VB.NET user group. A little bit about the group. We meet every month. The meetings are free of charge and open to the public, and we cover any and all topics related to .NET. You can find meeting information on meetup.com for both past as well as future meetings. I'd like to give a big thank you to our sponsors, Tech Systems and Inedo. When we were meeting in person, they provided the meeting space as well as the pizza and the refreshments. Also like to give a big thank you to PostSharp and DevExpress for providing the raffle prizes, which will be using the eval form to raffle off a couple of their licenses. We'd like to thank NIS Technologies for providing the web hosting services. We have a special offer from Manning.com. You can save 35% on a selection of books, and you can use the discount code MTPCLEC21. And the link will be provided later in the chat window. Some general information. Please keep in mind that participation is always encouraged, and there is no such thing as a stupid question. So feel free to ask whatever's on your mind. We're all here to learn from each other, so please don't hesitate. Also ask you that whenever you're not speaking, to mute your microphones just to avoid any background noise. And we like to keep it casual but organized, meaning jump in with any questions or comments at any point in time. But at the same time, we want to give our speakers enough time to go through the slide deck as well as their demos. So for tonight's presentation, we have a special meeting where we have three authors that have gotten together and published Pro Microservices in .NET 6. This is a book from A-Press and currently available on Amazon. The authors are Sean Whitesell, Rob Richardson, and Matt Groves. A little bit about the authors. Matt Groves, he's been coding professionally since the 90s. He's currently the project manager for Couchbase, and he's authored attribute-oriented programming in .NET, as well as the Pro Microservices book in .NET 6. He's a blogger and frequent speaker at conferences and user groups, and he's also a Microsoft MVP. The one thing about Matt that stands out is that he lives in a city called Grove City. That's one thing he and I have in common. I grew up in a city in Egypt called Nasser City. So I guess we have something to talk about there. The other author with the group is Sean Whitesell. Has been programming for 20 plus years. He's the president of the Tulsa .NET user group, and they've been meeting online recently, and they cover a lot of great topics. He's a cloud architect with TokenEx, and he also has multiple black belts in martial arts. Impressive. He's also a Microsoft MVP and an ASP insider. Last but certainly not least, Rob Richardson. He's been building websites in ASP.NET, Node, React, and Vue. He's a Microsoft MVP, author, conference speaker, as well as teacher. And he blogs regularly at robrich.org, and you can also find him on Twitter at rob_rich. And so with that, we'll turn it over to Sean, and we can go ahead and get started with our presentation.
All right. So you can tell that picture of Rob was just last week. His beard grows really fast as well. So it's what we're going to talk about today is microservices. And thanks, Sam, for pointing out the book. I really appreciate that. We just got that out and into the wild at the first part of January. And that's been a nice, interesting labor of love. And a quick shout out to my co-authors for helping me out. They just hit the ball out of the park when they came in to help me get that project done. So I cannot see anybody, which is an interesting view, but I do see chat. So if there's any questions, you're welcome to pop them in chat. I'll see them. Or if you want to come off mute, you're welcome to do that. So this is the first time that us three have gotten together to do a presentation, although we've individually have our presentations on our specific subjects that we love to talk on. This is the first time for us all together. So what we're going to do is we're going to start out with my presentation about microservices. This is a slide deck that I've put together, a conference talk that I put together, and when I was actually creating the first chapter of the book. So we're going to talk about a large kind of a swath of things about microservices, but we're going to make it super, super simple too. And that is, if you're interested in microservices, don't do them. That's the quick thing. Don't do them. Well, I say that, of course, we're here to do this for a reason. But this is where the idea that it came from, is that the easy way is the wrong way. And the reason for that is, and I have lost my controls. There we go. The reason I say that don't do them is because so many people hear the buzzword and they think, okay, we got to do this. Can we have this done by next week? No, you can't. So a large part of this discussion is going to be talking about what is microservices and what do we do about them. And then we're going to talk on other specific topics. I'll hand it off to Matt and Rob as we touch on our various things, and certainly our specific disciplines that we wrote about in the book. The main goal, though, is to talk about that microservices is about architecture and less about programming. A lot of people have that misunderstanding. This is why the buzzword-driven development kind of gets people into trouble. So when I say don't do microservices, don't do them unless you're willing to really dive in and understand that they're more about an architecture, and here's so many of the things that come along with them to do them well. So, like I said, this is my slide deck from my own personal talk on this. We are going to jump around quite a bit, but as we go through this, so the first thing I want to touch on is, what is a microservice? Now, the problem with that question is that there's multiple answers, depending on who you ask. And for a while, I didn't have an answer. I finally came up with my own. A microservice is simply a tiny monolith, we'll talk on that, with a tight focus on a domain. It's not about size, it's about focus. And the key principle right here is that we need to understand that microservices is not about the size of code. It could be 50 lines of code, it could be 500 lines of code. That's not the point of it. It's about a tight focus on a domain. Okay, what is a domain? We're going to discuss that as well. So some of the key tenets about microservices is that they are independent applications, and I will repeat that till the day I die. Microservices is not just about architecture. A microservice itself is an independent application, meaning that it needs all the love and attention as any other application. That goes so far as to having its own code repository, to its own pipeline for deployments, to the various stages from dev to staging to test to prod, etc. And microservices communicate over a network. And this is one of the key things that kind of gets a lot of people by surprise. We think, well, we have this method calling this method, it runs in memory, and things are extremely fast. When you bring things out, that functionality out to a microservice, it has to communicate differently. It's not across a memory boundary anymore. It's going to communicate over a network. Maybe it's directly using an RPC style, that remote procedure call style that goes over to an IP address, and or maybe that microservices communicates by using messaging and messaging patterns, and we'll discuss a little bit of that later as well. And because they communicate over a network, there is an inherent latency that's added to that communication. So you have to be aware of it. And you also have to judge that functionality that you're pulling out to be a microservice, or maybe it's new functionality that you're bringing into your organization, into your product line here. Is that process able to tolerate the latency that is brought in because of now communication over network? And I know you may say, no, we got a fiber. That's still much, much slower than a call going across a memory boundary. A microservice also has a single responsibility. This is where we come back to that tight focus on a domain. When we talk about a microservice provides functionality, let's think of it like this. What if we have our accounting functionality and all the things that go with accounting and all the calculations, all the formulas, all the algorithms, and we're going to say this is the functionality that the accounting software does for us, and it's all wrapped into this little tight focus. All right, well now that can be, I say can, it's your call on this, can be a microservice. Then you may even get to some point where you're like, well, wait a minute, we're having some competing problems, which we'll talk about later. And these competing problems is suggesting that we actually have more than one responsibility. It's not single anymore. It's trying to do too many things. You might even pull it out. So now you have one microservice that's for your accounts payable and another microservice for your accounts receivable. It's very possible. And a microservice should be owned by one team of developers. Now, let's be clear on that the opposite is not necessarily true. A team of developers can have one or more microservices to their responsibility of what they're developing and what they're supporting, etc. But you do not want to have a microservice that is owned and supported by more than one team of developers. You will have competing deadlines, competing decisions, competing opinions on development styles, etc. And a microservice should be individually deployable, meaning that you should be able to deploy that microservice without having to deploy everything else in the architecture at the exact same time. Now, what I'm saying is you want to eliminate your code coupling, what we call tight coupling. You want to loosen that as much as possible. And of course, things are joined, but where are they joined? It's not joined at the code. You want that joined at the business layer, the reason that it exists. And that microservice and whatever's calling it, they exist for a reason. They exist to fulfill business functionality. That's where they should connect, but not at code. And moreover, again, I keep repeating this, it's an architectural style. It's about the architecture of the solution instead of just code, because honestly, and we're going to touch on this in just a second, you can develop microservices in many different ways. So when we talk about a monolith, let's understand exactly what we're talking about. A monolith is a complete set of one or more assemblies, and this is your compiled code, and it has a lot of independent functionality, but it's all in one, what we say, a deployable code base. Meaning that something in red, well, that could be the accounting stuff, and then the greens, the functionality, well, that could be stuff that handles shipping. We got stuff that handles for sales, for invoicing, things like that. But they're all wrapped in together. And when there's an upgrade, everything goes up with it when it gets deployed. So what you may do is find that you need to extract some of that functionality and pull that out to a microservice. Well, that's one way of doing it. And you'll maybe use things like the strangler pattern and others that talk about how do we pull and understand our code, and where do we provide that splitting piece to understand how we're going to pull that out into a microservice. Now, the other option is maybe you're adding functionality brand new to that architecture. It's very possible. And that is, in fact, it may be even more likely. Maybe the current stuff you have in the monolith, you leave that as an older version, and your new version is brought in as a microservice, so that it's out of it has the new features, it has the new upgrades, etc. that you need, and then you start working on abandoning the code that's in the monolith, and that's perfectly fine. Rarely will you see a total migration of where that monolith is just exploded apart into multiple microservices. It has been done. We're going to talk about that in just a moment. But rarely will you see that done. Now, when we talk about microservices architecture, we want you to understand that it is an implementation of distributed computing. The idea here is that you're taking your computational needs and you're distributing them across multiple servers that need to talk to each other. This is that network call. And the picture here is to to kind of depict maybe 5 different microservices with multiple instances of each of the microservice, and they're communicating in some form or fashion in various ways. So why should you use a microservice? Well, I told you earlier, don't. But like I said, a lot of that is really because don't do that unless you're wanting to really understand and go through the process and be willing to fail, because doing microservices is expensive. It's expensive in time and money. You're going to do a lot of proof of concepts. If you cannot do that, I suggest holding off. There are other options. But if you can do that, if you can spend the time to learn, to grow, to do the POCs, to even deploy things into production and then pull it back, and that's been done even by some large companies, then you can dive into doing microservices with that attempt of doing them well. So when we get over to to deliver business functionality, what I'm referring to is that when we have this need where the boss comes in and says, okay, well, we've got a new product, we've got to get this added to our system, and we need to get this done because time to market of this new functionality is critical to our business. We've got to be the first one there. So can we have this done in, say, a month or two? And you're like, no, sorry, it's going to be 6 months at the least. That doesn't go over well. Or when you say, look, if we do this, it's only going to add more fragility, and our code's already fragile, it's going to break more things than it fixes, it's going to be a problem. So you may find where you're going to need to bring in a microservice so that you can deploy that functionality quicker, safer, with a little bit more stability. Then the code that you're touching is more about not making calls or making new calls, and less about trying to integrate and force things together. And I am talking fast. I'm trying to shoot through this, and no, I'm not going to go through all the slides because I really want to hand it off to the other guys as well to do their part. But we're going to do this, talk on a few of the key pieces here for just a moment. The things about microservices, you got team autonomy. When you have a microservice, you get to choose the best programming language for the job, depending on that purpose of that microservice. Let's say, for example, if it's doing analytics, well, .NET, you can do analytics with .NET, but a lot of people prefer Python. They think that is a much better language for that job. So if you're going to do a microservice to help analyze some data, you get to choose the best programming language for the job. And I say focused development, because now the microservice with its single responsibility is supposed to work on one thing. I don't necessarily have to worry about everything else in the architecture or in that monolith. I can worry about just what this microservice needs to do so that I can make it do that well. If you're already in an environment using Agile or Kanban, you're going to find that developing microservices fits in and works really well with that. Service autonomy, when we're talking about a microservice, should have a single responsibility. That's that tight focus on what job and what business functionality, what value does that bring. It should be really tight, and it should be to itself. It should be able to be deployed without having to deploy other services or the other monolith. Now, I'm referring to at the code level dependency. Now, if you're saying, well, we got this new feature and it does require that these 3 microservices and a monolith version gets deployed at the same time, that's fine, because then they're coupled at the business feature level, not at code level. Scalability. So now when I talk about multiple instances of your multiple microservices, you get to choose, well, are you going to run it on Windows? You're going to run it on Linux? What kind of servers do you want? And certainly if you're doing something like with Azure, you got virtual machines, or the virtual machines in AWS called EC2s, you get to choose. And certainly on the fly, go, I want so much CPU, I need so much RAM, and I need so much networking power, things like that. You get to choose your servers to help do that, and how many instances that you do that. Then as well, you're going to talk about, and Matt will talk about this in just a moment, about Azure Kubernetes service is just an example of hosting a microservice where you get to have the option for scaling and auto scaling and things like that, depending on your type of demand. Fault isolation. Your problems aren't my problems. And I have the quote that I saw this in a commercial. I thought it was funny, and it's certainly applicable here. Stay in your lane, bro. Think of it, for example, Amazon. If you go to Amazon and you're going to look at the page, and you find a product that you like, that product, that one page is actually supplied by multiple microservices. One for the product, one for the description, one for the suggested other items that you may like, one for the reviews and what other people have said about it, and etc. There's the one page is fed by so many different microservices. Well, what if the microservice that supplies the reviews and the stars, etc., has a problem? Should that stop you from purchasing an item? Well, no, because the functionality, although it's on the same page, the functionality is different. As long as I can log in, find an item, and then go throw it in my cart and purchase, then I'm good, even if the reviews didn't show up. So different processes held together with different microservices have their fault isolation where one group will not affect the others. Now, when we talk about who uses microservices, and I mentioned these three people right here, Amazon, as I just mentioned, and eBay and Netflix, those are three examples of large companies that went all in. They converted from a monolithic architecture to a complete microservices architecture, but not without their pains, not without a ton of struggle with that. And I'm sure that they put some things out there into production only to have to pull it back and do a little bug fixing, etc., and get that next version out there. But they were able to decide if they want to do this and go all in. And where you may not want to do that, maybe you want to bring in one microservice or two and not go all in, that's okay. So why should you not do microservices? Well, quite frankly, they're hard. Okay, I know, it sounds like a cop-out, but so is good programming. And I mean, we don't want to just copy paste and do what I do. You copy paste and hope it compiles. No, we want to do it well. We want to think this out. You know, how is this supposed to work in the architectural environment, and what data is coming in, what data is going out, how are we logging information, etc. Right? But as well, if your monolith is simply too small of a code base, you might actually find it easier to add some flagging in there, something like launch darkly, for example, and add some feature flags, and just simply make multiple instances of that monolith and using flags to determine what that instance should really process and work on, right? You will find that it's actually cheaper to do that, and what's called a distributed monolithic. And that's okay, right? And certainly it's a lot cheaper than doing microservices. But you may also find too that your monolithic code base is too fragile. There's so much tight coupling going on. You're going to have to spend a lot of time refactoring even before you could start doing things like the strangler pattern and pulling things apart, etc. Right? And if you don't have the team willing or ready, then you want to fix that first. You're going to have to get the team developed. You're going to get your team structure in place. You're going to get them up to speed on things like this talk, the book, for example, and many other great resources to help get them started. And you're going to have to be able to support that. It's a code base. It's a microservice is an independent application. Therefore, it needs all that love and attention. That includes support as well. And be prepared for a high cost of time and money investment in doing microservices. So some of the challenges, they're not cheap. Like I just said, they're high cost of time and money, and you're going to spend time learning and investing in there. You're going to have to understand the communication architecture. Are we going to do it direct with RPC, and we got to know the IP addresses in there, or are we going to do it synchronous type of business process where we have to have an answer quickly as possible from the microservice, or are we able to allow other things to work with it and have some time for it to come back when it can? Maybe we do messaging and use something like a pub sub model where we're going to let things out there. And this could be in a combination too. It doesn't have to be either or. It's a combination. So we maybe do pub sub where this happened, this invoice got created. Now I need other things in the architecture to react because of that. Where you may think, well, just copy files over to a server and you're done. Don't do that. Move away from that as soon as possible. Build up your continuous integration, your continuous deployment pipeline for each of the microservice. Yes, for each, including a code repository, the next line, because they are independent applications. They need to evolve independently. Networking, not my job. Well, it kind of getting that way, where now developers need to know about, now I don't mean in great detail about the OSI model, but know about that there is an OSI model, know a little bit about networking, and specifically what we're going to talk about is layer 4 and 7. And on the next slide, I'll tell you exactly what I mean by that. Security is becoming more and more of an issue. Well, I say that security has always been an issue, but security is getting more and more focus. And there's a thing called shift left, where we're trying to move the attention of security more and more onto developers. So we can try to fix security issues as soon as possible. You may think, well, I'm a developer, I don't need to worry about security. That's not necessarily true. You're going to want to understand things like TLS and OAuth. And why? Well, think of it like this. Let's take this example. I have a microservice and that thing processes my paycheck. Well, do I want just anybody calling my microservice? Maybe I need to control who has access to call that microservice and to get that paycheck information. But what about it being communicated over a network? Well, that's okay. It's going to be in a private network in the back. That doesn't mean that it's secure. So you're going to want to look about doing secure network traffic and using things like certificates in that TLS, that transport layer security. Common code. If you have common code, you got to be very, very careful because it's going to bite you in the butt. Sharing code keeps services tightly coupled, and this is where we don't want that coupling. It's okay at the business feature level, not at the code level. And here is the OSI model. So when we talk about networking, this is going to take just 2 seconds. We talk about networking. Physical layer, that's that cord that's going from your router to your computer, and now you're like, well, I got Wi-Fi. It's just an invisible wire. But you still have to handle that, even if it's from the router to the cable modem or inside of a data center. There's always that physical layer. So you got Ethernet and your Ethernet cables, your fiber cables, things like that. Then you go up to layer 3. This is where your IP addressing is done. So you have your IP layer, your ARP for routing information, ICMP, which is ping, transport layer. So now you got into TCP, which is transport control protocol, I believe, and UDP. And then all the way up to layer 7, HTTP. Why does this matter? Why does a person of microservices need to even know about this stuff? How are our microservices going to communicate? If we're going to use a network and we need to understand that a caller going to a microservice, let's say that they are going to call it direct and they need to know an IP address. Well, first off, that's bad. That just means you have one instance of a microservice. What if it fails? Now you're not resilient. So now you make multiple instances of a microservice. That means each of them are going to have an IP address if we do that model, right? Well, then if each of them have an IP address, how do I know which one to call? Then go to things like a load balancer. If, for example, you're in Azure and you have an Azure load balancer that operates on layer 4, which means that it's looking at the TCP packets and it's routing at the IP level. So it's going to help and balance that load across to your different instances. Okay, great. Now we're handling that as far as now I got multiple instances of a microservice that each of them are able to answer a network call. That's great. Why do I care about layer 7? Well, if you've heard of VC, that model view controller pattern, the R, which is for routing, is one of the letters they leave off on that. Routing is done when it takes the request that comes in and it gets routed to a controller. Well, that is done at layer 7. This is where coding is executing, our code specifically is executing at this layer. But you could also do things like layer 7 load balancing with programs like Nginx, for example. So we need to know about them because of things on where they operate in, certainly in the calls and stuff like that. Excuse me.
Sean, I've got a question.
Yes, please.
We mentioned TLS in the slide before, and
Yes.
now we're looking at the OSI model. What layer is TLS in the OSI model?
You're going to call me on the fly, are you? Oh, I know why you're asking this, because you have a slide for this. I think that's done at layer 5 session, but correct me.
It's in layer 7. And what's interesting about that is if you have TLS terminate at your load balancer, then that means your load balancer is a layer 7 load balancer, as opposed to a layer 4 load balancer that can route traffic, and then you have TLS termination at your service instead. So what's really interesting is the majority of the time that we are working in layer 7.
But you bring up another good point too, is that why does it matter to me? I just write a microservice. When we talk about securing that communication traffic to our microservice, if that TLS certificate is what's called SSL offloading, if that's done at the load balancer, then the communication between the load balancer to my instance of a microservice, then that is potentially not secure. So we may minimize our security problems, but we need to make sure that we understand where things are secure and where things are not. So good call out, Rob. All right, I'm going to skip over this section and, oh, okay, let's talk on this right quick. I mentioned earlier about the possibility of doing a distributed monolith, where it may be easier for you to create multiple instances of a monolith and just use feature flagging. The other problem with this is, what if you still go ahead and decide to start pulling pieces out of your code pieces out of your monolith, and you're going to pop that into a microservice, and then you realize it has a dependency, so you got to pull even more code from the monolith over to that microservice, and then you got to pull even more, and then you realize that you have included everything, including the kitchen sink. Instead, you have now created a second monolith and not a microservice. Got to be careful of that. You got to understand your dependencies. So as soon as that microservice no longer has a single responsibility and it doesn't have that tight focus on a domain, you're looking at building another monolith and not a microservice. Okay, let's break here right quick before I jump into this, because this is also covered in a little bit covered in my book, chapter 6. Are there any questions thus far?
I do have a question, but I think I might be jumping the gun. So you talked about how, like for Amazon, for example, it involves several microservices to build one page.
Mm-hmm.
So I'm thinking, obviously, if you had just one service that built the entire page, obviously it would be very time consuming, and it would be a heavy load on that one single service. However, if you were to use several microservices like you're suggesting, shouldn't you spread them apart on several servers? So that way, if they're all on one server, they're going to be as impactful as one big service, would they not?
Yeah, absolutely. So when you look at developing your microservices and you say this is the functionality that it has, you also get to decide, right, is that this is what that autonomy that comes in is. You get the programming language of choice, because maybe it's 3 different programming languages that are used. It's just an Amazon page. You don't care. You just see the result of a page on there. But you get your programming language of choice, but you also get your scalability of choice. You get your choice of servers. Your microservices do not have to all be on one server. They could be across a plethora of servers. And you're going to have for example, a load balancer per microservice so that it can scale, and that load balancer is aware of that microservice. So maybe you have the reviews microservice and you have the reviews load balancer, and maybe you've got the product description microservices. You're going to have a program description, product description load balancer. So you can have multiple servers, multiple microservices, multiple load balancers. Absolutely. And they could be of various server types, etc. Right? Hopefully that answered your question. Any
Absolutely.
others? Good. Okay, so I'm gonna shoot through this right quick. One of the things that I've heard about in the studies of microservices several years ago is, well, there's this rule that says if you have a microservice, that it needs to have its own database. I'm like, no, I completely disagree with that. Well, I was wrong, but I better understand the why, and this is a key piece to this. And I kept mentioning earlier about we don't want our microservices to be tightly coupled at the code, and that using common code can be bad for us. Well, it can and can't, but it really depends. And you really want to have your code separated so that each of the microservices, not the instances, but a microservice, such as your accounts payable and your accounts receivable, those independent microservices should be able to evolve independently. Even though they're accounting and maybe they share some common accounting library, you want to be very careful of what you share. Same thing regarding data. So here's the rule, kind of tweaked. If you have a microservice that is responsible for persisting data, then it should have its own database, meaning that it should be what is responsible for the data integrity of the data it's responsible for. If you have a database and you have multiple applications that are able to write data into one or more tables, and then this table over here and says, this application says, well, I've got this need, I got versus this need, you're going to have competing problems. This is where this example comes in. So let's take, for example, we have the typical monolith. It's got a lot of business functionality. It's all wrapped into one code base. And we have our centralized data repository. Inside this database, we have tables for accounts, customers, orders, order history, parts one, shipping history, logging. Oh yeah, okay, let me explain. Parts one. Okay, well, you see, as parts was evolving, right, that table, and we kept adding columns, right, because our applications grow, they change. Well, at some point, see, we had this conflict, so we added another table for parts, and well, naming is hard. I'm probably not the only one that's done that. Okay, so here's the point. We got to at some point in this evolution of an application where it says the schema of the data has to change. But the problem was that the table structure itself couldn't keep up, so they went and made another table. Well, that kind of is indicative of what's going on here. So let's go through this. Let's say we decide to create we still have our monolith, we still have our database, and now we have a parts microservice. And it has its database. And now we have an orders database, and it has a reliance on parts information. Then we even go so far as we have a shipping microservice, and it has its own database, and it has a reliance on orders information. So now we have this data reliance on each other's microservice. Shipping is relying on orders is relying on parts. What are we going to do about this? Because we have this rule, right? It needs to be it has to have its own database. Since it is persisting data, we want it to be the maintainer of the data integrity. What are we going to do about this? And now here's two options. The shipping microservice could call over and do a call over to the orders microservice to get order information. The orders microservice could call over to the parts microservice to get part information. Sure, that is possible, and it is a valid solution. However, at some point, you may find that all those calls are very chatty and could cause extra latency. What are you going to do about it then? Here's the suggestion. This floored me when I learned about it. Here's exactly what we're going to do. We're going to duplicate data. Like, I know, first you're telling me I got to have my own database, and then you're going to tell me to duplicate data. That doesn't make sense. Here's how it does make sense. Let's look at a part. Inside that parts database, we have columns for tracking information such as the part number, the name, the category, the color of the container, blah, 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 the manufacturing information, the replaces part number stuff, when it got discontinued. But here's the key thing. When we duplicate data, certainly to something like the orders database, the orders microservice, The order doesn't care about all that data, which means you only need to duplicate some of the data. Just enough information duplicated to fulfill the business requirements for that microservice. That's perfectly legit. In fact, that is going to keep it very independent as well. And you don't have a lot of the competing schema problems as the database needs evolve as well. So your orders microservice can now have a copy of part information just enough to fulfill the purpose of an order. And the same thing about an order, you could have that duplicated to the shipping microservice, so it has just enough information to fulfill the purpose of shipping that order. Now, here's the next problem. How are you going to keep them in sync? Well, then you do things like maybe messaging, for example. And I really want to fly through this because I want to queue up Matt here in just a moment, because we're going to talk about containers and how we're going to host microservices. So let's fly through this right quick. We're going to set up a message bus. Now, if this kind of hits you sideways and you go, wait a minute, isn't this just service-oriented architecture from 80s, 90s kind of era, 2000s type of era? Yes and no. The thing about an SOA, service-oriented architecture, the problem with that is that the middle pieces, that enterprise service bus, became more problematic, and it became more of an issue because all the logic kept getting into the middle piece, and that's not very productive. With microservices, as I've heard this, microservices is SOA done right. Okay, or as Martin Fowler puts it, it is smart endpoints, dumb pipes. So now the message bus, for example, is just a transporter of messages. It leaves the business logic in the microservices where they belong, and it helps them to stay in a position where they can evolve independently. So what if we have things like our monolith and our order microservice, our parts microservice, and our shipping microservice? And then we say, okay, well, we've got we have a brand new part. So the administrator logs into the system, creates a brand new part, which fires off a message and inserts that into the parts database. So now the parts database is aware of it, but nothing else. Okay, then an order comes in for that part, maybe a few others. So now an order is created through the message bus. So now the order database now has a record of that, and with the information from the parts microservice to get that information into that database. So now we have that duplicate. But then the administrator notices there's a typo. There's a typo in the description of the part. Okay, so they go through the system, they update that, when it queues off another message, and an update message of some sort. And it updates the information to the parts database. But what about the part information that got duplicated into the order database, the order microservice? Well, since it's an update to a part information and says, well, this is something we care about, we're going to react to that message as well. So it could be like a pub sub type of message. So the message goes off that says, update this part information. The microservice reacts to that message, updates its database for the parts description. The order microservice also receives and reacts to that message, and it goes through there and says, hey, I do happen to have an order for that part, and there's the typo, so I'm going to go and correct that information. Now, should you? That's entirely up to you. Can you? This is a quick example. So you can use messaging patterns to help keep your data duplicate, but also in sync. And so that you can do, as well as doing different messaging patterns, like if you're going to do competing consumers or pub sub, depending on what is going on and what your needs are. All right, I'm going to skip some pieces here. Okay, this is where I am going to stop at this point and hand this over to Matt. So is there any questions before I stop?
I have one additional question if no one else has one.
Okay.
So let's assume that I'm an angry database administrator. explain to me again, why is it that I should have separate tables for the same thing?
So that they can evolve independently. So not just the microservice has to evolve independently, but so does the data schema. The data itself will evolve, and because they're going to have different purpose. How data is treated, for example, if it's the same data that the orders microservices handles, but you may also have another microservice for analytics. And you're going to need that same kind of data, but you're going to need it duplicated. You're going to send that over to a data lake, for example, so that you can do analytics against that. It's still duplicate data, but it's also structured differently. Something else, and Sam, I'm glad you asked that because I did forget to mention, not only do you get your choice of programming language in the microservice, but you can also then have your choice of the type of database for the different microservices. For example, what if your monolith is using SQL Server and you want to keep other type of order information, but you're going to use that in a NoSQL type database? I recommend Couchbase, for example, and I know why. So Couchbase is a great NoSQL database that can easily be leveraged for microservices, but it's going to store that data in a very different way. So now you can say, well, I can change my cost. I can and actually choose the database server and system and structure that's more specific to my needs of the reason that microservice exists. Does that help?
Honestly, it does, but I think it raises a couple more questions, but I'll save those till the end.
Okay.
Thank you for taking the time.
Let me tell the story with a little bit different slant. We focused on the technology decisions, and those are brilliant. Why should we duplicate our data? Well, the Angry DBA is going to talk about database normalization. Database normalization was a technology developed to be able to store data smaller. Now that's interesting when we have 5 megabyte hard drives that cost us thousands or hundreds of thousands of dollars. In the 60s, that was a concern. Today, you can fit 5 gigabytes in your nose. I love the metric by Richard Campbell, where he's like, how much data can I fit in my nose? Can I fit a terabyte in my nose now? So denormalization was a really important thing in the 60s when storage was expensive. Today, that's no longer a concern. Simultaneously, if we have one big monolithic database, if I want to make a change to the schema, I have to go interview the entire rest of the company. Hey, are you using this column? Are you using this column? Are you using this column? Well, maybe we have this legacy application that might be using this column, so we can't really delete it. How did we end up with parts in parts 1? Because we wanted to deprecate some columns, but we couldn't because some other application is doing it. If a microservice owns its own data and the microservice isn't using that column, we can delete that column. And so we can develop faster by having more distributed data stores to match our distributed microservices.
And as you pass it over to me, Sean, I can actually kind of show another piece of value that you might have in what you're calling what we're calling data duplication. So
okay, you got it. Oop,
all right,
hit the right button.
oh, there we go. I can share my screen. So I was going to skip some of this because you covered a lot of it already, but you know, I have a whole session I do on autonomous microservices and making. You mentioned autonomy in your presentation as well, Sean. So a lot of overlap here, but you know, a microservice architecture. One of the main benefits is to help with scaling. So you can scale individual pieces of your architecture. But some of the challenges that come along with that are these things listed here, and one of them is isolated failure. I was going to skip this, but I think since that question came up, it's useful to talk about. So if we look at a microservice, just a picture of it, microservice architecture, we have all these services, and these are all running potentially on different machines, right? And they're all communicating with each other, perhaps through HTTP or some other network call, right? If we're in a monolith, right, it's just a function call, right? So either these all work or none of them work. But in a microservice system, we could have the user service itself go down while the rest of the system is still up, right? So what does that mean if service 1 needs to make calls to the user service? Basically, that means that it's still all broken, even though it's only the microservice, only the user service that's down. So we're not really isolating failure here. So we're still a single point of failure. This is the so-called microlith approach, where we're just moving function calls across the network. That's all we're really doing, and that comes with a whole set of problems. So how do we isolate this failure? And what we want to do is we want to be able to make service 1, service 2, whatever else, still be able to work even if user service is temporarily offline. So one way we can do this is we can cache the data that we need instead of asking for it. And this improves isolation and improves resiliency of the system. So just as an example, and Sean basically had a very similar slide here, if we have order, delivery, and payment, and they all depend on user service. If the user service goes offline, I'd like to keep the orders coming. I still want to take people's money if they're willing to give it to me, even if the user service is down. So we set up some kind of asynchronous communication, a pub sub, a Kafka, RabbitMQ, whatever. And when the user service, when a user service is managing its own data and it updates a user, we're going to publish that change out to these other events. And those events can then take that user information and cache just the parts they need, as Sean demonstrated, so that if the user service is down, they can just fall back to the cached copy until the user service, hopefully comes back online soon, right? Now, there is a issue of eventual consistency here, right? But the trade-off here is that we can keep the system online mostly to some extent and keep taking in orders. The cache data might be out of date for some short period of time, right? It's not synchronous. It could be seconds, could be minutes, hopefully not any longer than that, but it could be. So, I like to think of microservices systems as I do humans, right? Real life is eventually consistent, right? Real life is not strongly consistent. So if I change my address, I fill out a card, it might not get entered into the post office's system for hours or even days, right? So I have to make arrangements in the meantime for my mail. But I can do that because I am autonomous. I have control over what, my mail, my address, and the arrangements that I can make. I don't need to sit there at the post office and watch them and stay in the waiting room until they update their system and then go with the mailman to make sure that it gets to the right place. I can act autonomously. So there's trade-offs involved there. But I don't think of it as duplicating data. I think of it as caching data is the way I'd like to put it. So and Couchbase, as you mentioned, is great for caching data. So that's one of the reasons that people like to use Couchbase. So I hope that answers your question a little better. I was going to skip this part, but I think it was a pretty good segue and helped cover it as well. So I'm going to go skip back to where I was going to start. I'm going to skip past resilient because I think Sean covered a lot of this stuff quite well. We can always come back to it if we need to. More animated fire is fine. The one thing I want to talk about is once you've got a microservices architecture that supports individual deployment, so you can scale it however you want to, has isolated failure features, it's resilient, so some of the things that Sean talked about with staying in your own lane. The last thing we want to talk about is elasticity and making your services elastic. And I want to talk about what that means. So Sean did touch on this a little bit. Well, I think it's good to review because we're going to get into containerization and orchestration. So elastic means that we can scale out a service by adding more servers or more nodes to accommodate more load, right? So we just ran a Super Bowl commercial and now everyone's coming to our website and we don't have enough capacity. We need to add more machines to perform more operations. And so the typical pattern to deal with this is called service discovery and, as Sean mentioned, load balancing. So we talk about the network stuff. A request comes into our load balancer. Let's say it's the top left box there. And that needs to direct traffic to one of, in this case, 3 different nodes that we have available. And so it doesn't necessarily know the IP addresses of those nodes, because they could come and go, as we'll soon see. So it goes to a place called a service registry. And that's where, once those nodes come online, they go to the service registry and say, hey, I'm here, I can start taking traffic. And so the service instance will go to that service registry and say, okay, this guy's open for traffic, let's send the traffic to him. And there may be different patterns to deal with this. So there's like round robin, there's sequential, random, sticky, all those types of things. But the purpose here is that we're taking a bunch of traffic and we're splitting it up to different nodes to handle that traffic. Now, the trick here is that these services each have to go and tell the service registry that, hey, I'm online, I'm ready to take some traffic. This is a pattern that may not be necessary for you to worry about too much anymore because of something called Kubernetes. Now, before I start with talking about Kubernetes, I do want to make the point, because this has come up in the book and come up with our discussions around the book, is that oftentimes containers and Kubernetes and Docker are strongly associated with microservices. You do not have to use those tools to build a microservice architecture. You can use whatever tools you want to. It's just that I think, especially for those larger scale deployments where we're talking more than a handful of microservices, that Kubernetes orchestration is going to provide you a lot of benefits, and this is one of them. It's basically got this service registry pattern built right in. So I create a Kubernetes service here with a YAML file. That's basically how you speak to Kubernetes, through YAML, for better or for worse. I'm not a big fan of YAML, but that's what you got to do. And so you set up a service here, and I say, okay, my service, it has a tag, it has some network stuff, has a name, and I can define that service. And then when I go to the service, Kubernetes will actually abstract those sets of what are called pods behind the service. So let's just go into a little more detail here. This is a deployment of, I think Sean mentioned Nginx. It's just a really simple web server. It doesn't really matter. It could be any kind of container here, ASP.NET, whatever. But what's important here is that I am declaratively telling Kubernetes I want a deployment, and I want you to use Nginx as the image there, the container, and I want you to make 2 replicas of it. So it's going to run 2 pods that match this whole template here, all right? And I'm just instructing Kubernetes to do this. And then it's up to Kubernetes to actually perform that and execute that. And so at some point there will be 2 nodes. Typically they're going to be different machines. They might be the same machine, but that's really up to Kubernetes to manage that. It's kind of like managing a game of Tetris. Make those pieces that come down, and you got to fit them in just the right way to maximize the usage on the screen. Kubernetes is the same thing with putting pods on top of or inside of servers. So in this case, I have 2 replicas. What happens if one of those Nginx containers were to crash or go away for some reason? Kubernetes is going to continuously monitor that and say, okay, I need 2 replicas here, but I only have 1. So now I need to spin up a second replica. And it's going to keep monitoring that. So Kubernetes is basically just looking at this YAML and saying, this is what I need. This is the state I want to be in. Am I in that state? If so, good. If not, what do I have to do to get to that state? So this is a lot to throw at you, especially if you're in a boot camp and you've never even seen YAML before. But this is the benefit of Kubernetes, is that we can declaratively just define how we want our deployment to look like. So that underscore there, I've highlighted replicas. If we need more capacity, for instance, that Super Bowl commercial, all I can go in here and just change that number to 10, and then save this YAML file, and that's all I have to do. And Kubernetes will then go ahead and spin up those 8 more containers, those 8 more pods to run and add capacity. Now, that's a simplified way of doing it. There's other more complex things where I can have Kubernetes monitor, let's say, RAM usage or memory usage. And if we're using 80% of the RAM, well, it might be time for add more resources, right? if we're using 80% of the CPU capacity, it might be time to add some more pods, and so on. So that's called autoscaler, and that's something that Kubernetes has available. That's something that also you can get with Azure and AWS services. So they have those features typically. The nice thing about Kubernetes, though, is that it's cloud agnostic. So I can build a Kubernetes deployment and deploy it to anywhere that implements Kubernetes. So right now, all of the big cloud providers offer a Kubernetes cluster. So Azure has AKS, Amazon has EKS, Google has GKE, and there's a bunch of other ones, but they're all implementing the same API. So it's a common set of APIs that I can deploy to Azure, I can deploy to Amazon, or I could deploy to both, for instance, if I want to have a multi-cloud strategy with my deployment. So that is something that Kubernetes gives you, is this orchestration that you don't have to do as much work when it comes to managing network, managing load balancers, all that kind of stuff. Kubernetes has built in. And so with that, you get the elasticity that is going to help your microservices stay autonomous and stay strong and bulletproof. That's the idea there. So that's all I really wanted to cover. I know I don't have a lot of time to go into all the full Kubernetes details. I've got other content out there if you want to. We can certainly talk about that if you have specific questions. But that's Kubernetes. The benefits of it there, just really quickly and briefly. So any questions here before I pass the control over to, I think Rob is up next, right?
I have a question. For those of us in boot camps who may not have seen this before, well, as you were talking about Kubernetes, the slide said K8s. Why does it say K8s?
Okay, I think I know the answer to this. So I'll tell you what I used to think it was, and I'll tell you what I think it actually is. So I thought it was kind of like a text, like when you write short texts and you say hello mate, you say M number 8, and it kind of sounds like mate if you say it like that. I thought this was like, oh, this is kind of a shorthand way to say Kuber80s, something like that. But no, I think actually what it means is I don't want to type the whole word out. So I know there's 8 letters between K and the S, so I put an 8 in there.
It's really close. Actually, it's the number 8 is the number of letters between K and S.
Yeah, isn't that what I said?
Yeah, like mate. But
right. No, but I thought I was thinking mate equals mate, and I thought it was going to be like this, and I was thinking K8 E's kind of sounds like Kubernetes. That was what I thought originally, but no, it is because we're too lazy to type out the whole thing. The same thing if you've ever seen A11Y, same thing. That means accessibility. We're taking out 11 letters there. Hey, Rob did the same thing. Look at that. No, that's a good question. That's a good thing to call out because that's something that I take for granted because I've been working on a Kubernetes chapter for this book for a long time, and that's something definitely good to point out. So hey, that's the thing. At the beginning of this session, Sam's slides, the only stupid question is the one not asked. If you're in a boot camp and you feel nervous about asking a question because you don't want to look like, oh, I don't know anything, I'm a newbie. Don't worry about that. Anyone who's going to give you problems for asking questions, I mean, you don't want to deal with them anyway. If it seems like something you don't know and you want to ask it, ask it. That's something that my father drilled into me when I was young. The only stupid question is the one you don't ask. So thank you very much, Rob, for stepping in and asking that. I'm sure it was on many people's minds. They were just maybe were worried about asking it in front of everybody. But yeah, this is, I always say that, I welcome any questions. Don't feel bad. Don't feel, I'm not going to make fun of you, anything like that. So go right ahead. So anything else before I hand it over to Rob?
And if you're really worried about asking a dumb question and you don't want to ask it in your class, my Twitter is Rob_Rich, and hit me up with it. I'd love to discuss it further.
Yep, absolutely. Same goes for me. I'm not Rob_Rich though. I'm M Groves.
Yeah.
All right, so I have a stupid question, and I'm not sure who wants to answer it, but If I'm new to microservices, how can I start by creating a very simplistic hello world microservice? And again, I don't want to jump the gun. I don't know if Rob's going to address that later, but
I think Rob's going to show some code. Maybe that will help illuminate. So that might be a good thing to do. Let me go ahead and hand it over to him, if I can remember how to do that. Let's see. Is this Rob? I hope this is the right Rob. Do you have control now, Rob? Yes, you do.
So while he's firing that up, that's a really good question. It's like, if I wanted to just do a file new project and kind of get started, and Rob may cover that in just a moment, that there is not you're not going to find a template where it's just like file new project, oh, here's microservice in the list. It doesn't work that way. You need to understand how is this thing going to communicate first, since it's an independent application. Let's take, for example, we want it to communicate over an RPC call. We're going to use Web API. So, and maybe this is where Rob's headed, I don't know just yet. So when you design your microservices, you may start with that in your first one. Why not do a Web API? Because you can use things like Postman to help test your communications with that. And something else that Rob's going to touch on, and so I'm queuing him up while his Visual Studio is loading. How do we know that now that we've got this microservice built, how do we know it's healthy? And so Rob's going to cover a lot of the details on understanding the health of a microservice. Rob, go for it.
Awesome. So I loved your question about how do we build a new microservice. If I'm in Visual Studio, I can say create a new project, and then it will ask me what type of project do I want to build. Now, if I'm building a website, I might choose ASP.NET Core Web App. That allows me to use Razor Pages. And the premise of Razor Pages is a URL maps to a specific page. So if I have that need, it's a great template to be able to do that. I can also use the MVC paradigm, which I really enjoy, where we can take requests in, it will go through the router, we can make various choices and ultimately choose a controller that can make some additional choices and ultimately choose a view. So we have a whole lot more layers of indirection that we can power from. Both of those will render web pages, so the output is typically HTML. It doesn't have to be, but typically it is. So how do I build a web API? Well, I'll come down in this list and I will choose ASP.NET Core Web API. Now, the cool thing about a web API is a web API will work with HTTP, with REST by default. Now, I can definitely use gRPC, so here's a gRPC web service, and I could definitely communicate through messaging, and so at that point, I might just create a console app and pull and push messages. But what's the easiest way to get started? I'll choose Web API and I'll push next, and away it goes. Now, I'm going to give it a really descriptive name of Web Application 1 in this case, so that I can get to this next screen where we can talk about using controllers. Now, the cool part with Web API is we can opt for controllers or we can opt for a minimal API. So with controllers, it's much like MVC controllers. We go through a router, we choose a particular controller, but rather than this controller spitting out a view, this controller will probably spit out JSON. Uncheck this, and now we're using minimal APIs. Minimal APIs is new in .NET 6 and allows us to make really fast, small microservices that might work really well. Perhaps these look a whole lot like Node and Express type services. So I'm going to hit cancel in this case and close out Visual Studio. And let's do a similar thing here on the command line. So I can say .NET New, and .NET New will spit out a bunch of different types that I can choose to make. So in this case, I could say .NET New MVC, and that would build an MVC app, or .NET New Razor, and that will build a Razor Pages app, or I can say .NET New Web API, and that will build a Web API app. I'm going to say help to get some more options, and one of the options here in Web API is this one right here, minimal. That's exactly the same checkbox that we saw previously, where we can say, I would like it to do a minimal API rather than a regular API. So let's do that. Let's say This is an empty directory so far. .NET new. I'm going to say web API. Web API. I'll pass in that minimal flag. I'm going to give it a name of site, and I'll give it an output folder of the current folder. Now, all of these flags are optional. If I just said .NET new API, it would create a new API, and it would put it in a new folder, and it would match the folder to match the name of my folder here. So I would get a second new service folder, and the content would be inside there. I chose to put it in the current folder and to spit out the current site. Okay, so now that I have that new service, let's pop it open VS Code. We could use Web API for our Visual Studio for this as well, but I'll just grab it here. Now, we have this minimal API. Everything is built into this program.cs. You notice that there are no other C# files in this project. We only have this minimal API. Now, the cool part is we have our same dependency injection pieces. We have Swagger here. We have a thing, but now we're specifically saying map get. If you hit weather forecast, I want you to spit out the details from this weather forecast method. And then I have a particular record, this class definition, that describes how I'm going to build up this weather forecast. Okay, we just scaffold that project, and now let's say .NET run. We haven't done anything else. This one class file will be able to launch a web server in a really elegant way. Now, the cool part here is it is a full web server. We can do all of the beauty of MVC. We could reach into an entity framework context to get at data stores. We could use Redis or Couchbase to be able to grab or cache data. But this is a real live web server running on a real live thing. Let's pop open that port, and we want to hit weather forecast, and we have the results. Now, even better, we might be able to hit something like Swagger, and we have a bunch of details about how this service works. So here's my minimal API. I'm going to click try it out, and I can execute it. And the cool part is, here's the curl request that it sent to go get that API. These backslashes mean this command is continued on to the next line. So if I wanted to execute it, I probably would want to take out all the carriage returns and the backslashes to get that to be one big command. But that's the command that it did. And here's the results. We got an HTTP 200, and we got 5 weather forecast results. Now that's cool. We have this minimal API. Do we want to maybe ramp up to controllers? Okay, so let's go up a folder and let's say Mictor web API, CD web API, and let's do a similar thing. .NET new web API. I'm going to give it a site, a name of site, and an output folder of the current directory. I definitely could have done this. Which one did I spell incorrectly? Oh, typing is hard. So I could have definitely done this through Visual Studio, file new, and go create a thing, but this gives me a little bit more structure in my service. We could definitely open this up in Visual Studio as well to play, but now our program.cs has a little bit more. It says add controllers. We still have Swagger in here, which is excellent. And we have map controllers. So by convention, it will now go reflect against all of our code, looking for anything that descends from controller or controller base, and rig up all of these routes. So we get the same behavior here. We have a weather forecast, but now we get a little bit more structure, a little bit more separation of concerns. Which is better? Well, it depends. If you have a really, really small microservice that only needs to do one little thing, having this one file is kind of helpful. If you want to spread out a little bit, or you're building a monolith, you have a lot of concerns, then having these separate controllers is really nice. Now, ultimately, if we .NET run this, we're going to end up with exactly the same experience. It is a web API. It knows how to accept JSON. It knows how to spit back JSON. And we can build up really cool microservices that way. So let's build it. Now we've got this service. Let's launch it. And let's hit the Swagger page again. And now we've got this really cool experience of being able to hit that web API. Now, in this case, we're not passing in any parameters, so it didn't prompt me for any, but we get those same results. Whether we're using controllers or whether we're using minimal APIs, we can build the same experience inside of .NET, which is really cool. So let's upgrade a little bit and let's talk about how to build healthy microservices. Well, right now we have a microservice, but if anything went wrong, then our microservice would kind of be dead. We don't really know what's wrong. We have this logger here, but we're not really using it to log anything. So let's upgrade a little bit and talk about how we might choose to log data. Now, logging is cool. Logging is about capturing a moment in time and being able to record all the details that possibly happened about that. So controller, this map info controller, and this map info controller is going to keep track of address requests. So I'm going to pass into this an origin city and a destination city, and I'm going to call out into this service inside my thing to be able to go get the details. Okay, so here's this service, and it's going to go reach into my configuration and go fire off a request. And I want to now log the details of this call. If anything goes wrong, I would like to know. So I'm going to do a try catch here. I'm going to grab the exception, and I'm going to log that exception together with some context around that. Now, I'm carefully logging the request parameters, origin city and destination city. I'm carefully logging the status code and the exception so that I can get, for example, inner exception details, stack trace details, and I'm going to send that all to this logger. Now, this iLogger of map info controller is built into .NET, which is really elegant, but where it goes is not. Now, I can definitely tune this to be wherever I would like it to go, and so we'll add a NuGet package here. In this case, we're going to look at this CS proj, and we will go grab, that is not the one that I expected. Where did I go? Okay. So we will include Serolog here. Now, the beauty of Serolog is Serolog allows us to direct these logs to whatever detail that we want to whatever destination that we want to. Now, typically when we take in a configuration, it does this path for us. So we're going to do it by hand this time, just so that we can get that configuration straight away. And we're going to pass that configuration into this logger. Now, this is a Serolog thing, and this allows us to go read that configuration and create a new Serolog logger. Now, when the Microsoft logger wants to send its log somewhere, we know that it's going to send it into Serolog. Now that we've got that created, we can do a try catch around creating our application, catching a log, a failure if it happens. And finally, we can close and flush that log to make sure that we've captured all of the logs before our application ends. So inside of our application, there's no difference at all. We're just using the standard Microsoft iLogger of whatever class we have, so that we can get very specific inclusion and exclusion rules. And now, where do we want to send this? Well, here inside app settings, I have this Serolog section that will identify where I want my logs to go. Now, in this case, I'm going to use serolog.syncs.file. I want to be able to write my logs to a file, but I also want to log them to the console as well. Oh, it looks like I'm only logging them to a file in this case. So I have a logs folder. I want to call it log.txt. It will automatically roll every day, so I'll get date-specific files, which is really elegant. And now I want to enrich it from various sources. Let me grab log context, machine name, thread ID. I can grab other properties, maybe request properties or response properties, and all of these will now go into my logs as well. I now get a whole lot more visibility of my system. Now, there is definitely a trade-off here. The more logs I keep, the more computation goes into capturing the logs, the more storage space goes into the logs. but it's really nice to be able to get to that spot where it's like, what happened? I don't know. Let's go look at the logs and go figure it out. Now, logs are amazing for capturing a point in time, but what happened? What led up to it? What happened after this? That's where a log is just a point in time. We might want to also add metrics. Now, I'm going to add metrics in a different way than I did with Serolog. Serolog is just a NuGet package. In this case, I'm going to grab Prometheus metrics. So I include the Prometheus ASP.NET Core package, and that allows me to start to create Prometheus syncs. Now, Prometheus is interesting because unlike logs where I push the log somewhere, instead, Prometheus is going to come ask me every so often for the logs. So I need to kind of keep them in place. Okay, so I've logged that, or I've added the package, and then here in my startup section, I choose to add, here it is, use HTTP client metrics. That will be able to grab details out of HTTP client and expose it as Prometheus metrics. I also have, I also grab other Prometheus metrics in interesting ways. And then finally, I create this map metrics endpoint. So now when Prometheus comes to collect details from my service, it will be able to grab them. Here's mapping metrics, here's collecting HTTP metrics. We've got lots of interesting things. So for example, here in my controller, I can now, my controller is really empty. It just calls into map distance service. So let's dig into map distance service. And now I've created these metrics buckets. Now the cool part about a metric is it is a quantity of things over time. Requests per second, exceptions per hour, failures per minute. And so these types of buckets will want to create stateful pieces here. So by the way, this is static. And because it's static, it will persist over multiple requests, where multiple requests might reinitialize this, this service. So here's my static counter, and this one is how many times do I call Google API. Google API will throttle me if I call it too many times, so I might want to keep track of these metrics here inside this. So here's the same service that we called before, where we pass in the origin city and the destination city. The Google Distance API key is kind of important. So we formed this URL. Now I'm going to say, let's increment this counter. I have called the API. So now in my Prometheus dashboard, I'll be able to say, how many times did we call it today? Or in the last hour? Did we get throttled by Google? If so, let's take a look at what used it. I can also collect labels per execution. So in this case, I'm going to increment a counter that is specific to both origin and destination city. Did I call this counter a whole lot with the same source and destination? If so, maybe I can cache that answer, and then I don't need to call this limited resource so often. So I built some counters, and then when Prometheus comes to hit my service, they will come into the metrics endpoint, and away it goes. Now, Prometheus is one example of being able to catch metrics, but it is a really common example. Typically, when you have Prometheus, you also have a Grafana dashboard to be able to visualize this. And so this Docker compose file that comes with this code actually spins up Prometheus, it spins up Grafana, and it spins up my microservice all inside of Docker containers. That's pretty cool. So we used logging to capture a point in time. We used metrics to be able to see content over time. But what about what led up to it? Now, if we have a failure in a particular service, we know all of the details about that request, the response, the context, the thread count, the user ID, but what led up to it? What called this service? What will I call next? And that's where we're also going to look at tracing. Tracing is a process of keeping track of the previous context so that as I spawn new work, I can go to the next context. Now, oftentimes when we look at tracing, we will pass a context ID, a request ID, a thread ID, something like this that will spawn, that we can pass through all of the services to be able to get from where we begin to where we ended. Now that's amazing. We have this context ID to be able to then collect all the details that happened with this particular request and analyze them all together. But what happens if we make two different requests? What if in the middle of executing our services, we not only call Google, but we also call PayPal? Or what if we call into microservice A and microservice B, and they continue the chain from there? In this case, we probably want to do tracing a little bit differently. And that's what's really elegant. In this example, we're going to take a look at using OpenTelemetry. OpenTelemetry is really new. They've worked on their tracing API, but they really haven't dialed out the metrics or logging APIs yet. But I've included the OpenTelemetry exporters for Jaeger and for the console. I've included details about capturing OpenTelemetry metrics in really elegant ways. And so now that I have this OpenTelemetry integration into my service, let's take a look at the content. I don't believe there's any changes here in my program. I don't think there's any changes in startup. Oh, I did grab the details of where I'm going to push these metrics. I'll push them to this Jaeger host. So here's where Jaeger lives, which is, here's where Jaeger lives, which is pretty cool. The beauty here is if you're running this locally, then localhost is probably where your Jaeger instance is. But if you choose to use this Docker compose file, then I'm going to spin up the microservice, and I'm also going to spin up Jaeger. And so the cool part is I'm going to override that OpenTelemetry Jaeger host with the name of the container. So it automatically forwards into the correct spot. Okay, so we've spun up our instance of connecting to Jaeger, and we want to be able to instrument all of these things. So we'll automatically reach into HTTP client and ASP.NET Core. So as requests come in or go out, then we'll be able to log those details. And with each one, it's going to grab a particular, in OpenTelemetry terms, a span. This span of work, this task. Each span is going to reach into the parent activity, the thing that spawned it, and go grab that parent activity ID. And then, as it spawns new tasks, it will pass in its current ID, and they can use that as their parent ID. Now, the cool part here is we end up with this really great chain of execution. So let's take a look at what a Jaeger experience might look like. Here's the Jaeger dashboard where traffic called into here, called into this microservice. Now this microservice lasted this long. It called into here, and this one lasted this long, and this one lasted this long. And so we can see that really elegant call chain. If I have an exception that gets thrown in this service, how did we get here? Well, it was because this service called it with these details. We could click into each piece and see the request and response details of that request. We can click into the ones all the way up the chain. So with this tracing details, if I'm trying to increase performance in my system, I don't need to optimize this piece. I don't need to optimize that piece. Maybe let's look at this piece. That one's taking up quite a lot of compute time. Or this piece, that's taking up a lot of compute time. We can visualize how things call other things. Why did this error happen? Because this one called it with this parameter, and this one called it with this parameter. So maybe we need to modify our validation here in this outer service so that it doesn't call the inner service with invalid data. That's really cool. So we got to see tracing, we got to see metrics, and we got to see logging. Tracing is logging is a particular moment in time where we might go really deep. Metrics are elements over time, so we're not capturing as much detail, but we're more counting how many per time frame. And then tracing is being able to capture as we go between services. So the cool part is now we can use each of these three pieces, logging, metrics, and tracing, to be able to diagnose a problem. So for example, maybe we're looking at our Grafana dashboard. We're looking at the metrics. I've got so many requests per hour, and that number is going down. Or I have so many exceptions per hour, and that number is going up. Well, why is that? Let's flip over to tracing. Let's flip over to logging and see if we find any really juicy logs there. Are there any big stack traces? Are there any interesting new events? Are there any events that are happening frequently? Okay, we found our particular event inside the Serolog logs, and now we can take a look at the details. Let's look at the context associated with this exception. Let's take a look at the user that created this, and ultimately, let's see if we can capture that tracing ID. Okay, now that we've got something unique about this exception, we'll flip over to Jaeger and we'll take a look at tracing. Let's take a look at all of the requests and responses that got us to this point. At this point, now we've seen a lot of details around this exception, and we've seen the traces around it, and we can say, oh, yeah, that service just recently got deployed, and it's now throwing garbage into this service. That's why we're seeing a lot more exceptions. In this case, we used metrics and logging and tracing together to be able to diagnose and ensure the health of our system. Now, presuming that we have microservices that are nicely separated and that are elastic and can scale up and down independently, we can start to replace or upgrade small services to be able to gain additional visibility and durability in our system. Logs, metrics, and tracing allow us to gain that visibility so that we can understand how our system is behaving. Now, you may not need all three. If you're just starting out, maybe logging is sufficient. But in time, leveraging each of the three allows us to tell more of the story and get more details in it. Serolog has been around forever as a NuGet package. It's a great way to pull in those details. Prometheus is a great cross-platform experience. And OpenTelemetry is a brand new system that looks like it may take over from Prometheus as the cross-platform tracing, logging, and metrics service of choice. So these are three different approaches inside of .NET. There are three different ways of monitoring our services to see they're healthy. And there are three different techniques that you might use to ensure that your services are healthy going forwards. Any questions about logging, metrics, and tracing?
We've left them stunned.
And Jim is asking why I never switched away from VS Code. You're right. There were no slides, so I had nothing more to say there.
So let's do this, Sam, if you're wanting to, we can go to the panel side of this. So open this up to anybody with questions regarding any of this.
Yeah, absolutely. And again, just a reminder to everyone, feel free to jump in with any questions, preferably verbally or in the chat window. But again, there is no such thing as a stupid question.
Hey guys,
I've got a question.
Sorry.
We spent a
Sorry
long
about it.
time explaining why we shouldn't do microservices. Why are we here?
Well, hold on a second. Dominic had a question.
Oh, go ahead, Dominic.
yeah, I was just going to ask about Azure functions. So is there a point, where you might want to use Azure functions instead of some of the other options here? I know that with Azure functions, you can just use application insights, and that would enable you to have all the metrics and the logging and telemetry data too. So I really like using Azure functions. I was wondering if that would be something that you would have like pros and cons when you would use Azure functions versus something else like Kubernetes for your microservices.
Good call. Azure Functions is a great way to have burstable services. It's a great way to build really, really small, compact microservices. It's also really tied to Azure. Now, if we're on AWS, we have Lambda. Google Cloud has a similar paradigm. If we're in other things, there are function as a service mechanisms to be able to accomplish this. In the context of the book, we tried to stay cloud agnostic, so we didn't derivate too far into Azure Functions, but I agree. If you can get a function, that's kind of the ultimate tiny microservice. It's pretty cool.
The other piece, though, to consider is that like an AWS Lambda and an Azure Function, for example, they have a max runtime. So you're only allowed to run for so many minutes at max, right? What if your microservice is really meant to offload some heavy computation? And so you're going to need a large volume of time to process a lot of data. So that's when Azure Functions is not suitable, or Lambdas. But you're right, Dominic, that you should go down that thought process of, you want to work to your strengths. You want to see what is available to you. And just like Rob mentioned, a few options for knowing that your microservice is healthy, Applications Insights is another great option. So we only mentioned a few, but you're absolutely right. There are others out there.
And App Insights is really cool because you can tie it into Azure Web Apps. You can tie it into Azure Kubernetes Service. You can kind of pool all the things. If you're only in Azure, Azure App Insights is a great tool for keeping your services healthy. I love your point, Sean, about how in Azure Functions and in Lambdas, you have a time limit. What's really cool about that is you have a time limit, but you don't have an instance count limit. So if I can shard my work into lots of little pieces, I can queue them all. Maybe I do that in one Azure function, or maybe in my container, and I push all of those messages into a queue. Now, the queue gets pretty full. Azure Functions notices that that queue is full and will spin up a lot of instances of this function. Grab all that compute the answer really quickly. And so if it might have taken me, I don't know, a day to render that frame, or a couple of days to compute that big answer, maybe with 1,000 instances of my function, all doing a little piece of that, I might be able to get the total answer in a day of compute cost, but in 10 minutes of wall clock time. Once that function, that sprawl of functions is done, the billing that I get charged is also done, and the answer gets returned to whatever service needs to consume it from the next step in the message queue. Azure Functions can be a great way for those big burstable workloads that I don't need to be running all that often.
Right, thank you. I had one more question for you would you say for microservices, you would never not use message queue? It sounds like if you don't use message queue, you're going to open yourself up to a lot of problems, is what it sounded like.
There's a
I
couple of
don't know.
ways to communicate between services. Message queues is a great one. HTTP is another great one. And so ultimately, it's about, how real time do I need this? If I don't need an answer in real time, a message bus is awesome because I can just publish the message and forget about it. If I need an answer right away, maybe I need a gRPC or a REST call to be able to receive that answer in a timely way. Ultimately, as you're designing your architecture, a message bus is a good way to be able to communicate between services. It is a dependency though, and so your message bus needs to be available nearly all the time.
And I hope it was, if it was said that you must have a message queue, that was incorrectly said. The idea is that there are times when you want to consider them, just as Rob was saying. It is a tool that you can use. It's not that in particular is not a requirement. So you may do direct calls, you may need to do messaging, or both.
Okay, yeah, I was referring to the part where it was talking about single point of failure. So if your apps communicate, your functions communicate, or your microservices, and one is down, then the whole process is kind of broken. So
So yeah, if you're not going to use message queues, or even if you do, I'll still say this: there's things like Poly, the library called Poly, right, that you can use for retry logic and circuit breaker. I highly recommend those because what if the microservice has, for whatever reason, trouble sending the message to the bus because the bus just happens to be down? Well, it's another thing dependent on a network, so it will need a retry logic as well. So yeah, there's definitely other things to bring in, other considerations to bring in.
Okay.
Good questions. What else?
No questions for me. I did just want to say Part of the reason I'm here, I'm an engineering manager, and we're hiring for senior and principal level engineers. It's a startup, so you can get some equity if anyone's interested. Feel free to reach out.
Ooh, so it's a blockchain company?
No, it's not yet anyway. It's just a tech company.
That's awesome.
Mhm.
Devin, I saw you unmute yourself. Do you have a question?
Yeah, this actually relates back to when Sean was talking about Amazon, eBay, and Netflix using microservices. So we all know that Netflix uses probably all the microservices for their video and whatnot, but is Amazon using it just effectively for like their marketplace, or are they using it all over for like AWS services and Amazon Prime Video?
So well, to be honest, I don't know to the full extent that they're using it, but my understanding is, at least with the Amazon Marketplace, because that's actually, if I'm not mistaken, that's also a different organization. It's still Amazon, but you have the retail side, and you have AWS, the cloud provider. The cloud provider uses a different, and I'll say a fabric as kind of a loose word. So not everything in AWS is done by microservices. I know, for example, AWS Lambdas is ran by a system called Firecracker. It's not microservice. It is a system for allowing things to be treated like microservices with an extremely fast start time and that kind of code-based management, or at least microservice type environment management. They might use a microservice to kick off the creation of a virtual machine, but obviously the virtual machine itself is not a microservice. So they may leverage microservices on the AWS side, but they, just like Azure, they have their fabric, if you will, that is behind the scenes for handling communications and their tasks of what they're going to do, such as like spinning up a VM. But most of the, if not all of the retail side for Amazon is microservices.
Cool, thank you.
I have a question.
Yeah.
So I'm not super familiar with it, but I'm just curious where something like maybe SignalR would fit in with this architecture.
Great question. SignalR is a great way to create live connections between services. Under the hood, it can use WebSockets, which is amazing. And so if I want to have a connection from the server to the browser where I can send messages or make procedure calls, update data, then SignalR is a great resource for doing that. Now, if I'm in containers trying to call between the services, I definitely can. I can just reach out to the service and call it. But I can't call from the server to the browser very well, and that's where SignalR really excels. If I'm calling from the browser to the server, then I just use REST. Calling from the server to the browser, I get SignalR to start up a connection. Now I have a hub that can send and receive messages. And so it's a great real-time communication piece.
But you're more likely to see SignalR between a browser to a server than you are to see SignalR between services.
Okay.
But usually with between services, you're going to have like the gRPC type thing. So with REST, with RPC, is I'm going to make a call, and his code example is Web API. It's going to use REST-based calls. Well, what if that communication needs to be more of binary data and not something wrapped in JSON? Then something like gRPC can be used for that. But you're really not likely to use SignalR, at least that I've seen, for cross microservice communication.
I completely agree. If you're trying to reach between services, then you can use HTTP or gRPC. You don't need SignalR. SignalR starts a connection from the browser and connects to the server and leaves that connection open forever, allowing you to get great communication between browser and server. Apologies if I was unclear earlier.
No, that's good. Thank you.
Good question. What else, guys?
With regards to testing, what unit framework can you use for that?
Yeah, we mentioned that in our book too, chapter 7. So if you're going to use RPC style communication, there is a library called PactNet, P-A-C-T-net, and you can use that. So even if you have two different microservices, obviously two different microservices, but one calling the other, and let's say, for example, that those microservices are developed by two different teams, you can use the PactNet file that is shared between the teams. So if I know what I'm going to, and thank you, Rob, if I know that I'm developing my microservice to call another service, I'm going to go ahead and set up my test using that library, and it basically records a call. Now, it's kind of puts itself in as the mock, so it's recording that information and it spits it out to a file. Even if that other service doesn't exist yet, then I can give it to the other team. They can develop that microservice as the provider side and run their test against that very same file to make sure that the expectations are met across the microservices. In cases like that, you definitely have to have strong communication between the teams so that what the expectations are met. I'm going to call you, here's what I need from you, this is why I'm calling you, and this is what's going to be provided, and you're going to have that kind of a contract that's between them. If you're doing like using mass transit, for example, as a messaging communication between the microservices, mass transit has a testing library built in. So you can leverage it for saying, I sent this pretend message and it hit this, did it hit my my consumer as expected? And you can leverage that library as well.
Great, thank you.
Yep.
What's cool about microservices is that all of the test tools that we're used to, XUnit, NUnit, MS Test, they work just fine for validating the business logic inside of our microservices. So continue to write unit tests in those tools. But now we have communication between services that we also need to validate. And so, as Sean pointed out, sometimes that destination service or that source service may not exist yet, or I may not have access to it inside my test. So I may choose to mock that communication. PactNet is a great tool for being able to do that, so that I can fake call the service and validate that my service behaves correctly in each of those instances. The beauty here is that we can record things like the service threw a 500 error or the service didn't connect, and we can get our service to or validate that our service behaves correctly in each of those instances. What's unique about microservices is that unlike memory calls, where we're just calling another function in our application, some of our business logic that we need to consume lives across an HTTP connection. So we need to make sure that we behave correctly with that HTTP connection. Now, the interesting point here then is our solution, our business system, is now bigger than any one microservice. So probably we also need to write integration tests that will go across all of the services. My great example is, so we have a shopping cart experience. We have a purchase path. Let's create a tool that will, in production, start at the homepage, get to the product catalog, add something to the shopping cart, get to the checkout part, and don't enter a credit card number, stop just shy of that. But let's run that test in production really frequently. That will validate that the communication between all of our microservices on this critical business path work correctly. If ever that unit test fails, we know, or if ever that integration test fails, we know we have problems in our business. And we really want to identify that before the customer complaint calls start. Let's run that integration test in production in a non-destructive, non-costly way as frequently as we can, maybe once an hour, maybe once every few minutes, so that we can validate the integration between each of our microservices. A unit test that validates a microservice may only prove that the service behaves the way we thought it should, not that it integrates well with others. So let's also run integration tests between our services, which probably needs to take place in production.
Hey, Rob, make me presenter right quick. I'm going to share my screen and show something interesting that I put in the book.
Yeah, let me find the button. Now that I'm not presenting, it moved.
Yeah, of course. The fun of having multiple monitors.
Yes.
One of the things that I did for, make sure I'm sharing the correct screen. Okay, so one of the things that I did is I loved drawing using vector-based stuff, and I can do a lot with PowerPoint. So the image in chapter 7 of the testing pyramid, I drew in PowerPoint. And let's say I'll move this off right quick, and I can go this, and I can select my items. You can right click and say save as picture. This is how I made a lot of the pictures in the book. So this, to Rob's point, when we talk about the testing pyramid that originated by Mike Cohn, there is an evolution of that, if you will, for microservices. So instead of just being a 3-tier where it's got UI, business logic, and UI, and then integration test, and then unit test, now it's a little bit more complex. So to Rob's point, talking about the unit testing that we still want to do in each of the microservices, this is where we're proving our logic, as I had it earlier, our algorithms. If you're going to do tax codes calculations, for example, you still want to test that your calculations are correct. Integration is now when this thing is reliant on something else outside of itself. For example, a file, a database, things like that. And then we work our way up to maybe our reliance on a contract, our reliance on another service and type of communication, and then an end-to-end testing. So you can see how the lower you are, the more automatable those kind of tests are. So I wanted to show this right quick as a kind of a graphic example. When we're referring to testing microservices, there's various layers to that. So hopefully that helps a little bit in that conversation.
What's also really cool about this diagram is that it is that triangle. We'll have a very few amount of end-to-end tests. They take a really long time to execute. They do a lot of things. We'll have a lot of unit tests because they run really fast. They don't have a lot of dependencies. They don't reach out to external services. So as we walk up this testing pyramid, they will probably get less automatable, and we will probably have fewer of them, and they'll probably take longer. So let's build lots of unit tests to validate our functions work as correctly. Let's build some integration tests to validate that we can call other services and other services can call us. PACnet is perfect for this. Let's validate that our components play well together. PACnet actually is great for validating contracts between services. And then the one that I mentioned, I call it an integration test at the time, but it is really that end-to-end test. Start at the home page, go to the shopping cart. That's probably a different microservice. Add something, or go to the product catalog, add something to the shopping cart. Shopping cart's probably a third microservice. Maybe we had many microservices to paint our product catalog. Let's go to the checkout experience. That's probably another microservice. You see how we're walking through each of the services to validate that they work well together. That end-to-end test is really cool, but probably only attainable in production.
Yeah, Rob, thank you for pointing that out. I forgot to mention that the reason that we have a pyramid shape is to indicate that there should be more tests at the lower layers as you go down. So I'm glad you pointed that out. Any other questions, even regarding this? Anything else?
Hey guys, so I had one more question I just thought of. So
Sure.
So let's say that you have in the example earlier, you have the orders service, microservice, and let's say somehow some bad code got pushed into production, and so the data was corrupted. So when the order got created, somehow some field was missing or corrupted in some way, like the customer address. So that went and got persisted into the subsequent databases. So you have like the orders database service is kind of corrupted now with this data that was wrong, and the address service, and so on and so forth. So if you have a situation like that where you have the corrupted data on these various databases, what would you recommend in terms of mitigating that? Do you have to go into each database, or would it have to be a message queue problem where you create a new like updated event and then it updates it?
So you basically listed off two viable options, and the difference between them is going to be up to you and the team. And do you have a dedicated DBA? Is maybe they're more comfortable, and depending on the size of the situation, maybe they're thinking, okay, give me 1 minute of downtime and I'll get this fixed, or something to that effect. So it really depends on the disaster mitigation that you've got and the strength and capabilities of the team. So I don't mean to sound like doing a cop out. There's just so many other things that that answer depends on, but it's a valid thing. So that if you've got a bad piece of code, well, one, you got to stop it. So you're going to stop your damage and get that code replaced. Maybe while that team is fixing that code and getting a release out there, you're going to get a DBA or somebody else that's going to go and help patch data and put it back the way it was. Maybe you can do that through messaging, depends on how easy it is. The problem is then each of the microservices has to be aware of that message, knows to react and how to react to that message. So more than likely, you're going to fix that code and somebody's going to go fix the databases independently.
I'm going to take a little bit of different approach and talk about how these microservices and service bus can work together. What's really cool about a service bus is that it's a great way to communicate asynchronously between services. So let's pretend that order service is spewing garbage. Let's shut it down. Now, we're not missing orders. People are still checking out. It's just maybe we're not charging their credit card yet. And so whenever we get a new order service that comes back online, we can restart it, processing those messages from before the corruption happened. And the cool part, we just now recompute that garbage data and we repair that corruption. Now, maybe we had to delete some orders out of the database. Maybe it's doing an update instead of an insert, but we're getting that data cleaned up in the process of reprocessing those messages. And then the downstream messages that will come out of that service are similarly now solved based on this thing, and the downstream services can process those updates in the way that they normally would. I suspect if you identified a problem in the order service, you can probably solve it just with the order service in most cases.
Great, thank you guys. That answers it.
Good deal. So the other thing too is that when we mentioned that a microservice that persists data should have its own database, yeah, there's going to be the argument with a DBA that says, what if it doesn't really have to be its own database? What about its own schema in the database? So for like Oracle and SQL Server both have schemas. So you can do, instead of DBO, maybe it's a different schema, that type thing. That's viable. You want that separation just so that you don't have multiple applications competing for the changes of the data schema and when the models change. The other thing that may come into this, and we discussed this in the book as well, is you're going to have different types of data patterns. So you may have, and in fact, Rob's example kind of reminded me of this. When an order, for example, has a state, when you do an update or a delete, you're deleting data, you're harming data, and you really don't want to do that. You should try to stay away from that. So what if instead, when the state of the order needs to change, what's being recorded is a change of state, and that pattern is the event sourcing. So then each record is a change of state, and you replay those records to get a final results. So it's, you don't have one record as a result, you get multiple records that this order, when it was new, this is what it looked like. When it was amended, this is what it looked like. When it was changed to paid, this is what it looked like. When it changed to shipped, this is what it looked like. When it came back as returned, for example, this is what that order looked like. Now you got independent records of the state independently of that one order, and you also have a built-in history of that. Doing microservices, now you don't have to do microservices to do event sourcing. It's an option that is provided when you do things like this, and you bring that kind of conversation into the discussions about the architecture when you design these things out.
So I've got a question. Does that mean if I want to do microservices, I need a message bus?
No, we covered that earlier, and no, you don't have to have a message bus. If you don't do a message bus, they got to communicate somehow, right? So you're going to have that direct RPC call. So if you don't do direct RPC, then I highly suggest a message bus. Now, what kind of message bus?
Yeah, exactly. If your DBA is saying there will be no message bus, that doesn't mean that you're barred from doing microservices.
Well, right, and I'd be surprised if a DBA has the ability to say no message bus, because they're not going to the database directly, or even to the database servers directly. They're going between the applications. But there's also types of message bus out there. For example, from ActiveMQ, RabbitMQ to ZeroMQ, that acts entirely different because it doesn't have a central system. With ZeroMQ, each of the different pieces are the piece was, instead of being centralized queue management system, it's spread across all of the nodes. So even that provides various options to how do you handle and manage messages. Would you agree that you need to mitigate a mitigation plan before deploying a microservice in the case things data transactions are written incorrectly? Well, that's another big discussion. So the quick answer is absolutely, you need a mitigation plan. You need a, what if it goes down? You need to say, well, what happens when it comes back online? When we talk about this database, for example, SQL Server has various types of consistency levels, strong, eventual, etc. And like things, if you want to use Cosmos DB, for example, it has 5 consistency levels. Why would you use one versus another? Then you have another problem, what's called RTO and RPO. I spelled that wrong in there, RPO. So between the time that you have an outage to the time that you're able to mitigate it and get it fixed to the time that you're able to get your data back online. So you got the difference between your time for RTO and your time for RPO. There are so many other discussions in this. This presentation was a rather quick flyover view just to help get people really started down the right path, but this is far from conclusive of everything that needs to be discussed.
I would also add that you shouldn't stop doing microservices until you do the big architecture thing. Have these conversations, begin talking about mitigation plans and contingencies, but don't hesitate to develop because you don't have a plan yet. Do those in parallel, or get started with a smaller project in your organization, maybe one that has less visibility or less criticality, and see if splitting that into microservices makes sense. That'll also give you a good sense for what is the right size microservice for my architecture. What is the domain boundaries between things? Does it make sense to cut the services this way or that way? Once you kind of get a feel for how to architect these services and how to combine them together in interesting ways, then you can start to take on the larger, more critical, more disaster-prone areas of your code base and start to pick them apart. Like other things, microservices is a pattern. It's a way for architecting a system for durability and scale. And if you don't have those problems, it may not be the right solution for you.
Makes sense. Anyone have any other questions or comments? Pardon me.
Well, I had a blast getting to present tonight. If you have any other questions, if you find a question tomorrow or next week, I'm Rob_Rich on Twitter. My DMs are open, or hit up robrich.org and click on the email me button and let's chat.
Yeah, great presentation, guys.
Yeah, and we do appreciate feedback because, like I mentioned, this was the first time that all three of us presented at the same time. So obviously, we're going to probably get together a little bit later and see if we can kind of fine tune this, so the next time we do this together, we're going to do a much better job with the presentation side of it. We've already been on 2 different podcasts, all 3 of us, but we didn't have to share our screen, so it's just us audio recording. So. But yeah, feedback is greatly appreciated. We always take that into account, and so that we can make it better for anybody else that asks us a question and want to learn. So, but yeah, this was great, and I appreciate the opportunity.
And likewise, we appreciate your time as well. Highly appreciated. All right, if you don't mind, can I take back the presenter? And just have some wrap-up announcements before we call it a night. And let me go ahead and share my screen. All right, so again, the title of the book is Pro Microservices in .NET 6, Sean Whitesell, Rob Richardson, and Matt Groves. For the wrap-up, basically, tonight's meeting is being recorded and will be posted on YouTube. The link will be sent in chat in just a second. Actually, let me pause and do that now. All right, so you got several links that I posted in chat. First is for the YouTube channel. If you would please subscribe, and you'll get notifications once the video has been edited and uploaded. And also with the tech events, which I will cover in just a little bit, that'll be posted on my blog, samnasser.blogspot.com. And lastly, the feedback eval. That is the last link that's listed there. If you would please take a moment, fill out the eval so we can provide some feedback to our speakers. Also wanted to cover the special offer that was provided by Manning.com. We're receiving 35% on a selection of books, and that link is also provided in the chat window as well. As far as technical events, on March 1st is the Ohio North database training. Chances are if you work in .NET, you're also working with SQL Server, and that user group targets a variety of topics related to database and specifically SQL Server. So their meeting is online. It's going to be March 1st, which is the first Tuesday of every month. And then on March 9th is the Azure Cleveland user group, and I will be the host for that meeting, and we're going to be talking about Power BI, and that meets on March 9th at 6 p.m. online. On March 17th is the Great Lakes Users Group based out of Lansing, and that is going to be on the 3rd Thursday of every month, and the meeting information can be found on the meetup link posted there. And then lastly, March 24th, which is the 4th Thursday, is the March meeting of this group where we're going to be meeting. Technically, we don't have a speaker lined up yet, so that is to be announced, but something is in the works and should be posted soon on the meetup site. One of the things that we always like to cover are job openings, and Tech Systems, who's been a big sponsor of the group, they always have jobs posted at techsystems.com/itjobs. In addition, I think Dominic, you mentioned that you have a couple positions opened at your office.
Yep. Sorry, I was trying to come off mute there. Yeah, so the company's called Broadloom. We're a tech company in the flooring industry, pretty much the largest company. It's a startup, and I will share the link in the chat. Hiring for a number of positions, principal, senior, also DevOps. We're looking for a security specialist as well. So pretty much every department is needing some assistance.
Excellent. Is there anyone who's looking for work? Feel free to either enter your name in chat or speak up verbally.
All of us from Tech Elevator in about a month and a half.
All right. So those 6 weeks will go by pretty quickly, I'm sure.
No doubt, and we'll see you again.
Absolutely. And then lastly, my contact information. If needed, my email is snasser@nistechnologies.com. You can also find me on Twitter @SamNasser. And my blog, once again, samnasser.blogspot.com. So there I post various technical articles as well as tech events that are accessible from the area, whether it's online or within a nearby driving distance. And then I also invite you to connect with me on LinkedIn. And so if there's no other questions or comments, I thank you all for attending and look forward to seeing you all next month.
Thank you so much for everything.
Thank you. Appreciate it.